Welcome back, boys and girls. In this video, I'm going to show you how you can potentially take your if statements and replace them with objects. The reason you might want to do this is to make your solution overall more maintainable, all different characteristics like being more flexible, making code more readable, more modular, more composable, etc. I'm going to go over a couple of scenarios which highlight these topics, but your general takeaway should be that if statements aren't necessarily bad, you should be using them. It's just sometimes when you have certain oversights about your software, they tend to get out of hand. So in this video, I'm going to show you some examples of, let's say, if statements getting out of hand, and we're going to refactor the code to what I think is its better form, and I'm going to try to state the reasons why as well. Don't forget, if you're enjoying the video, leave a like and subscribe. If you have any questions, make sure to leave them in the comment section, and don't forget to check out the description. With that, let's go ahead and get started. Here we have a simple ASP.NET Core application, a bunch of files over here. Here we have our dependency injection container. We register a couple of services. If you're not familiar with ASP.NET Core and you just want to know how do I replace my if statements with objects, I'm going to try to do a little bit of a better job of explaining what is happening. So on these routes, I have a couple of scenarios that I want to cover, and then over here I have these static functions which get bound to this route. So effectively, if I make a request on /good, it's going to go to here and execute this function. So here's the first scenario where this is effectively your handler and you're trying to use a service. And on your endpoint, what you have is either you're changing the behavior of the endpoint or you're changing a behavior of a function inside a service, etc. Effectively, you're depending on the iWeb host environment, which is saying, are you in development? Are you in production? Are you on staging? Are you on some kind of other environment? A very superficial example, but not a superficial scenario. You effectively have some kind of service. In our case, this is a handler trying to consume another service, and or vice versa, or a service itself is changing its behavior based on which environment it's located in. So what are the potential problems here? First of all, if you need to change this behavior somewhere else, you would end up with code duplication. So then if you want to revert the change of this, you would effectively have to go to multiple places wherever you're consuming this service. So that's obviously not a good choice to have to remember to change multiple places if you're going to be changing this logic at all. The second approach that you would have is you would take iWeb host environment and you would just inject it into your GUID service. If you're reusing this service between applications, some of which may be on a web server, maybe this is going to be on the user interface, but effectively it's not a web host environment. So now you're depending to be in some kind of environment. So it's not really good here. It's not really good there. Where should this if statement belong? A common thing that you're going to notice with this approach and the other approach is replacing your if statements with objects really sometimes means taking these if statements and pulling back earlier, making the decisions earlier, effectively allowing you to replace those if statements which are deep inside your logic with objects which can be arranged earlier on. And this is what we're going to do. We're going to take this if statement and we're going to pull it earlier. The earliest that we can pull it is to this service resolution. Over here, we can get the service provider, where we can get the required service, the iWeb host environment. Let me quickly turn this into a function. So we will have our environment service where we can check. If environment is development, do one thing, and otherwise, let's go ahead and keep returning this GUID service. Okay, what actually goes here? Well, this is where you would create your dummy service. So you would implement another service, let's say GUID dummy service, where you would take this implementation and you would supply it over here. The interface here, you no longer need it because, well, this definition of this interface is kind of silly altogether, just the placement of it. But hopefully you get the picture here that I'm just implementing the same interface and I am pulling my decision of what service I want to resolve closer to its inception. And I would say that I don't want to return a GUID service, So this interface, depending on the environment, will resolve either a good demi-service or a GUID service. Now, all I'm left over here is I can actually go ahead and eliminate this if statement and no longer depend on the iWeb host environment. The next example that we're going to have a look at is defined use cases. So this may speak a little bit closer to some of you because as you're learning .NET, you get introduced to a lot of projects which use the repository pattern. So you would have product order, stock repository and whatnot, which are then consumed by product stock order services. And it's a I can't remember what it's called, the horizontal slices you effectively call them, and then you get a bunch of spaghetti between these horizontal slices. So the gist of the example is as such. You have some kind of service, product service, and you're gonna wanna list all of your products. You're gonna have to make a decision, right? You have many users. You have admins, managers, auditors, etc. And if it's a regular user, you might not want to give them the Stripe ID. And for the administrators, they're going to have a different UI, so they will actually want to see the Stripe ID, and that's what you're going to display. So you're varying your query, you're varying the data that you are returning by the user role. Now, this is just a single example of how the logic inside these services may vary based on the context of who is trying to execute this logic. So the problem that occurred here is what Martin refers to as the single responsibility query. This is where a lot of people get the concept wrong. They're thinking, okay, I have a function that gets all products and it's only really doing one thing. The main idea behind single responsibility principle is that there is only one reason for change. So if administrators need new information on their product board, they would effectively want this part of the function changed. When it's another customer, or let's say a regular customer, not a visitor, they would want this part of the function changed. So now you have two reasons for this to change. Are you trying to appeal to customers? Are you trying to appeal to administrators? Are you trying to appeal to managers, visitors of your shop, etc.? So multiple reasons to change. And this is again where I personally would try to ditch this product service, and I would refactor this to having two classes that would look something like this. I would list products independently for the administrators and independently for customers. The database injection, I didn't add Entity Framework Core or any dedicated database services. Just think of this as a database service being injected into its own class, right? The HTTP context, because we're effectively trying to get rid of this if statement, replacing it with objects, again, I'm pulling it up. I'm trying to get rid of this if statement, and the dependency on this HTTP context is going to go away because the decision whether I want to do one use case or another use case is going to be decided earlier, maybe somewhere over here in this HTTP context, and probably should just inject the user over here where I can perform this check. I'm gonna take the body of this all function. I'm gonna slap it in here, check this whole thing on the user, and as for the queries, we're gonna go down over here, take the all function, put it on the first and second object. Both of these services would get injected over here. Or what you're actually most commonly going to find is that actually these services will have their own separate endpoints, and now you don't have this if statement at all. You just have your administrator controller or endpoints for the administrator, and you have your endpoints for customers. And one big mistake, if you're listening very closely, a lot of people try to build like CRUD APIs that you can interact with clients, and this is where you have those cars /1 ID, etc. If you design your API that way, that's generally not the API that you want for your application. Your application is going to have more dedicated commands, more tailored commands, and those are two separate APIs. Again, following the single responsibility principle, the first API where it's tailored to the application that you're building it's going to change based on what you are going to need. The other API that is publicly exposed and has these CRUD endpoints, which are more granular but less effective. You would effectively have to do, like, let's say 3 general calls instead of doing 1 more tailored call for your application, okay? So as I was saying, potentially this gets split into its own endpoints, but here we've effectively pulled up the if statement. If we're pulling it into another endpoint, it would be 1 more of these guys, okay? So this one goes over here. This logic goes over here. And some people might worry about dry duplication. And again, you're not really repeating yourself. Remember that administrators are going to be the reason this changes. What you should be worried about is if it is reusing the same logic, if you're changing this, it's also going to change for other users. So you're actually breaking functionality by applying too much dry. So then let's go ahead and take these 2 services just to complete this service. So list products for customer, so cust and admin over here, comma, and there it is. So a solution that was effectively very badly designed in that the all function on the product service would be overloaded. It's trying to appeal to too many places, but now you have these individual reusable modules that you can also take this and you can confidently say that, okay, whenever the functionality on the administrator dashboard changes, nothing is going to change on the customer side, right? And speaking a little bit more about the modularity that we have managed to achieve here, we actually have classes, 2 classes now instead of 1 function. And some people may be like, is that a good thing? Is that a bad thing? Well, when you have classes, you can do the following thing, and I want you to think about this. When I'm using JSON serialization, I can have a piece of data and deserialize that piece of data to a object structure. And whatever that object structure is, I can call a function on the top level object and it can consume its nested objects to perform some kind of work. So if you effectively have some of these modules, you can arrange them using data, and that's what more or less the next example is about. Again, a very tightly knit, complected scenario here where the timing functionality, the logging functionality is not very reusable. We cannot take this functionality and maybe twist it around. Do we want to log first? Do we want to time it later? Or do we want to time it first and then log? So I'm going to go through effectively picking this apart first into modules. So creating something like a time and also defining an interface for a function. So ifn, just going to scroll down over here. We're going to go super simple. It's just going to be 1 parameter in, 1 parameter out. I think that's generally all that function needs. Carry on the generic definition, and we apply a function to the parameter. So time is going to implement ifun, and it is going to accept an ifun as well. All right, we're going to call it next. Make this a little bit smaller. And then I'm going to transfer all of the logic that I had over here to the time. So we got the stopwatch, we start it, we stop it, and we apply this function over here. And then we have the results. We will then do the same with the log. So I'll just put 2 G's over here just to disambiguate it from potentially any other built-in loggers. Get rid of the stopwatches and just log the result. Now, potentially you might want to say that we're losing this stopwatch elapsed, to which, you can potentially say, look, thistout parameter that we are outputting, to preserve the shape of the function, we can say, okay, if you actually want this, let's say that the result, if it is of a certain type, we can go ahead and timed. So I don't really have this interface, but you can capture this information and return it up the chain, which if you're using a JSON serializer at the end, eventually it will get serialized to JSON and return to your browser. And if you're using mediator when you're working with commands and responses, you would effectively do a similar thing. So anyway, we got one arrangement, we have a second arrangement, and we still have time and log, and we can potentially do something like this, where the function that I'm going to resolve, I'm going to use time and log over here with a switch statement, and we're going to say true, true, where I would return new time. And inside of it, I would supply log, inside of which I would have to supply something like, okay, I'm getting a value. Let's just give the value back. For all of the generic parameters, I would have to say string, string. And then I would also need some kind of generic operation that would effectively satisfy this lambda. Let's quickly copy this function over here. We're going to call this same. We'll just have a t here. And no parameters over here, and t in and t out will be the same. Let's implement this, and all this is going to do is return the same p. Let's make this a little bit shorter, and this is just a malarkey that you would have to do if you want to actually work with functions, but as you would work with them like this, but as if they are objects. Okay, so anyway, this is what we return if time and log are true. If we have true false, we would have just the new time without the log. And then if we would have let's say false true, we would just use the log, and otherwise we would just use the new same string. Okay, and there we have it. Let's actually just quickly specify the interface that it should put all this stuff to. Finish this up quickly with an apply on the payload, and there we go. Now you may be looking at this and you say, look, we got rid of the 3 if statements, but we now have effectively 4 cases in here, and 1 case where log runs before the time. We just have more stuff now, not less. And that's the point. Yes, we do have more stuff, and we still did get rid of the if statements. We did pull them out. It's just about giving this function a correct arrangement. Giving something a correct arrangement of services currently depends on these 2 parameters. It doesn't need to. What it can actually depend on, and is if I actually write this, let's say, a little bit better, where I will say, look, the first character is going to be t, the second character is going to be l. What I'm trying to depict here is it's going to be, actually we can just still have this as a character tuple. So wherever I have truths, or let's say actually it should be like this. This should be, let's say, empty. This should be the other way around, just with a log. And now this different definition unlocks this arrangement for me. So we did indeed get rid of the if statements. Now all we have is a way to say, which is this way, a way to express what arrangement of services do we want. And now we can surface this arrangement depending on this expression. Now this expression can come in the form of Boolean values. This expression can come in the term of characters. This expression can come in terms of data, a JSON structure, or anything else. The only thing that's left here is to effectively take this structure and move it into a separate service, which is going to produce this structure for you. You can call it a factory. If this structure actually ends up executing this code, then it becomes actually the interpreter pattern, where it's going to interpret this structure to perform some kind of actions. All in all, again, we had some functionality in this function. We extracted it into separate modules, and because these things that we've extracted are actually so reusable and composable, we said, okay, let's now define some kind of language for putting them together, and whatever arrangement we've managed to put together, we're going to wrap another service in it. And that's effectively all I wanted to show on the last example, and as an outro to the video, I'll just recap the things that I tried to highlight here. In the first example, when we removed an if statement, we were depending on the iWeb host environment. So what we actually did is initially there was a mistake of saying, look, this service should behave differently depending on this other thing. Now we remove the dependency. Wherever that dependency exists, that's the place that's going to decide what you should be using. Now, with the defined use cases, when we were creating our service, our repository, perhaps we were lazy or we didn't understand that there are these different areas in the business, and depending on which business area is asking for what or the action that they're trying to do, perhaps it's one business area, but it's different actions around a same type of object, and that resulted in tons and tons of if statements in your function, all in the name of dry. We want one function, and it really wasn't very configurable. You would have a lot of parameters, an object with many properties that you would have to check in order to perform different actions on objects and return different values. So here we got rid of the if statements to effectively say, this part of the function is its own thing, this part of the function is its own thing, and we can actually confirm that by saying there's actually these parts of the business which are connected with the first part of the function, and the other parts of the business connected with the other part of the function. With the third example, once we can identify these modules that we're carving out, can these be building blocks of our application? And in cases of things like time, log, audit, these are very reusable pieces of logic. And if you want to wrap something or say that something should be part of this, you can wrap it in a common interface and then create your own language for arranging these services together. These may actually more conveniently to C# people look like class attributes or property attributes, etc. And then you would have a bunch of metaprogramming and reflection to arrange it when you're actually executing it. But this will be it for this video. Thank you very much for watching. Hopefully you enjoyed it. If you did, please leave a like and subscribe. Was this advice useful or not? Please leave a comment. If you still have any questions, please leave them in the comment section as well. Again, don't forget to check out the description. If you would like the source code for this video as well as my other videos, please come support me on my Patreon. I will really appreciate it. A big and special thank you goes out to all of my current Patreon supporters. You help me do this work. As always, thank you for watching and have a good day.